Hello? Yeah, that's great. So, hello and good morning, everyone. I hope you have had a very pleasant night. And today, we are welcoming you all to the keynote lecture. And for the keynote lecture, it is organized in partnership with the university and the ISWI, that is the International Student Week in Ilmenau. And I wouldn't say much, but just present to you the plan of the day. So the plan of the day, we will have a welcoming speech from Professor Zadler, the president of the university. And then later, we will have a keynote lecture, the first keynote lecture from Prof. Schmid. And so during the keynote lecture, please take some notes and prepare some questions for a later discussion. And then we will have a short break for a later keynote lecture from Professor Daniel Lee Chen that came from France, from Toulouse, here to Ilmenau to give us an intriguing keynote lecture on AI. So without further ado, I will invite Professor Zadler for his speech and the introduction and welcoming you all.
Do I have a mic?
Yeah, sure.
Yeah, thank you. Yeah, thank you very much and good morning. It's a great pleasure to welcome you here in the Audimax, the largest lecture hall of our university, for this joint keynote joined by ISWI 2023 and DS Academicus of our university. So welcome to our university members, students, colleagues, and a special warm welcome to our international guests from all over the world. Not all are here right now. I know there was a party yesterday, so perhaps they join us online. Yeah, I would like to say great that you are here. After these 2 years of pandemic, I remember 2 years ago I was invited for a talk at ISWI 2021, and together with my colleague Martin Ziegler, we stood in a seminar room in front of 5 or 6 students for giving our presentation, and the students were only responsible for recording and streaming our talk. So it was great to run the ISWI also in these times, but it was kind of boring compared to the times before and after the pandemic. So, and I also think it's important to meet each other, to discuss, to listen to other positions and arguments, and I think it has been lost somewhat in the last few years, not only in Germany. It would be very helpful if we come back to this. So the topic of the ISWI 2023 is the impact of knowledge, and I suppose that most of you have directly a kind of a picture or association in mind, and this is probably AI, artificial intelligence. So everybody knows now about AI and has something to say about AI. Obviously, where is an impact of AI, so we see it in our daily life. But as a computer scientist with, let's say, 25 years or more than 25 years of experience in this research business, and as a non-AI person, I'm still relaxed regarding AI, so I have seen a lot of hypes in the past. I don't think that AI, artificial intelligence, will have the same impact as the pandemic or as nuclear war. I think to have this power and impact is just a wet dream of the guys from the tech companies. Anyway, where is an impact? We all can use, for example, ChatGPT to generate such welcome speeches. I haven't done this, so I still own a little bit of natural intelligence, I hope at least, to formulate something. So, but we will see what happens. We see it in the products we use. We see it in our daily life. We will see it also in education, and therefore we are happy to announce our keynote speaker, Professor Ute Schmid. She's the head of the Cognitive Systems Group at the University of Bamberg. She is an expert in AI and especially in explainable AI, which is, from my point of view, very important that we understand what happens in these black boxes, for example, of neural networks. And therefore, she will talk about education and AI. Unfortunately, due to urgent other commitments, she is not able to be here. But thanks to the modern technology, she can join us, and we are looking forward to your talk. Thank you very much.
Yeah, hello. Dear President Sattler, dear Vice President Anja Geigenmüller, thanks a lot that you have invited me to TU Ilmenau to this event. Dear members of the university and especially dear international students, I'm very happy that I can contribute to your Dies Academicus, and I'm really sorry that I'm here not in person, but only online. I will now share my slides. The talk will be about 45 minutes. It would be okay to have a break at some point. At one point, I will ask you whether there are already intermediate questions to be discussed. I think we have time until 10:30. And I will not see you during my talk. So if there are some problems like that you can't hear me anymore or something, please somebody open the mic and make me aware of possible problems. Okay, I will now share my slides. Which you should see now. If not, please tell me. The talk today will be about learning about and learning with artificial intelligence, what everybody should know about AI and how AI tools can support teaching and learning. So quite a broad topic, and I will start with an introduction to AI. Don't worry, I will not talk too long about the history of AI. I think due to the discussions over the last years, all of you are aware of basic concepts and ideas and the history of AI, but I want to give you a context first. Later on, of course, I will also talk about ChatGPT and maybe its impact on university education. Okay, you all know that artificial intelligence is not some recent marketing invention of Silicon Valley, but that AI has already been founded as a part of computer science in 1956 by the computer science pioneer John McCarthy, also the inventor of the programming language Lisp, in Stanford. And he wanted to invite colleagues to a workshop, also all computer scientists of this early time. And he and all these colleagues have been convinced that many aspects of human intelligence can be formalized by algorithms and therefore can be simulated by computer programs. So this was the birth of AI. Typically, when you look at AI textbooks, AI is defined as the study of how to make computers perform intelligent tasks that in the past could only be performed by humans. This is a definition of one of the early textbooks in AI by Elaine Rich. You also know that digital transformation is not the same as AI, right? Digital transformation, however, provides for applicability of algorithms to data and also applicability of AI algorithms. The small graph at the top of the slide shows you that machine learning, especially deep learning, which we are all talking about today, is not the only part or the only family of methods of AI, but we have many methods, knowledge-based methods, as well as machine learning methods. And for machine learning and deep learning, other sciences contribute, most of all statistics and data science. You also should be aware that most computer programs you use every day are not based on AI methods. Yeah? So AI is in more and more applications, but AI is not everywhere. And this is a good thing, because when you apply AI methods, you give up requirements concerning correctness and completeness. Yeah? For instance, when you have in a car an airbag, the software which is responsible for the airbag to inflate or not inflate has no AI component, because there it's crucial that you have correctness and completeness guarantees. So when do we apply AI methods? We apply AI methods for two reasons. Either that a problem is so complex that its solution, or maybe its optimal solution, cannot be computed efficiently. So the older of you, or maybe also the younger, might know Hitchhiker's Guide to the Galaxy, the famous number 42, where a computer produced a result, 42, and nobody remembered the question, right? So problems can be very complex. For instance, the traveling salesman complex, the traveling salesman problem is such a problem. And for these very, very complex problems, we need heuristic methods and approximation algorithms. The other reason why you would apply AI methods is if you cannot describe your problem explicitly, yeah, then you cannot write a program. And in this case, you need machine learning. There you replace explicit algorithms, which you can program and inspect, by black box models induced from data. At the bottom of this slide, you see a small image, the typical IPO, or in German EFA, principle for information processing. So the usual case is that you have an input for a program, and this program is represented in symbolic form, and this program calculates an output. Yeah? For machine learning, or when you apply machine learning, you replace this explicit program by such a black box model, which you learn from data, and afterwards this black box model produces for inputs outputs. When you look at the development of AI research since the 50s, you can observe that the development has come in three waves. The first wave is defined by a focus on explicit knowledge representation. So in this time, starting in the 1970s, you have powerful inference methods with provable characteristics, and these systems where you explicitly program by means of rules typically are transparent and comprehensible. This has been the age of expert systems. However, in this time, the researchers from the domain of knowledge representation and inference dominated the researchers who did research in machine learning, which also started already back in the 1950s, by the way, because they said, well, what you are doing in machine learning can never be applied in real-world settings, because when you induce models from data, you have no possibility to guarantee correctness, because it's an inductive process. So what you are doing is playing around. However, the age of expert systems found its end in one of the infamous AI winters, due to the so-called knowledge engineering bottleneck based on Polanyi's paradox. This is the question how we humans can know so much more than we can tell, meaning that large amounts of our knowledge is tacit, it's implicit, it's not verbalizable. Think a little bit how you would explain to another human all the knowledge necessary to recognize a cat, yeah, in an image or in real world. This is simply not possible. You can describe some things like the size, that it has fur, that it has whiskers, but you will never be able to write a set of rules which is complete and which can guarantee that you always can recognize a cat on an image. And you can now replace cat by recognizing tumor tissue in medical imaging, recognizing pedestrians in autonomous driving scenarios, assessing the quality of a produced part in industry, and so on. This is all things you cannot verbalize completely, and this is exactly the point where you need deep learning. When you look at AI, AI is more than many, many other areas of research prone to very great expectations. There are not only the AI researchers responsible, but also the media and people from practical fields like industrial quality control or medicine or education nowadays. But these very, very great expectations typically are followed by very, very big disappointments. And in these phases, we speak of AI winters. So the knowledge engineering bottleneck has already been the second AI winter. And the time when I did my habilitation thesis in 2000 in AI about interpretable machine learning was the time when the so-called winter without end started. Yeah, but we all know that this winter without end ended with the big bang of deep learning. So the second area of AI is the second wave is the focus on machine learning. And this is mainly due to impressive successes, especially for image-based classification. And the big breakthrough has been that we, with certain deep learning architectures like convolutional neural networks, CNNs, are able to do so-called end-to-end learning. What does this mean? When you look at the image of on the bottom of the slide, where you see two boats on a lake, before CNNs, what you needed to do has been to apply computer vision algorithms to extract features from this image, like color histograms, texture features, and so on. And this feature extraction has been the bottleneck of machine learning and in general of AI, machine learning for image data. So with the CNNs, it now became possible that you have that you have the possibility by means of these so-called convolution layers to apply filters, to learn filters, which help you to extract features as part of the machine learning process. These CNNs have been made so successful actually by a PhD student. Yeah, so you can do something really very, very impactful in research, even when you are only at the stage of a PhD student. Alex Grzeszewski has been PhD student of Geoffrey Hinton. I think this is a name everybody knows nowadays because Hinton is the father of neural networks, and he was the head of AI research at Google. And you might have read in the press some weeks ago that Hinton quitted his job as Google because he warns about the dangers of current development with generative AI. Okay. So the CNNs have been a breakthrough. Let's look again about the achievement and how this came along. When you look at the graph at the top of this slide, you see the so-called top 5 error in the image in the ImageNet challenge. And this has been started in 2010. This has been 4 million images with 1,000 categories like dog, cat, boat, bird, and much more specific categories for plants, animals, buildings, cars, and so on. And what you see is that this top 5 error decreased significantly between 2011 and 2012. And 2012 has been the CNN called AlexNet, the first CNN which has been successfully applied to this ImageNet challenge data. And you see that we have improved over the time to very, very good performance rates. Why is there a 5% error for humans? If you look at the categories in the ImageNet challenge, you will understand this, because there are very special categories for plants and even animals, where typically, if you are not an expert in this area, you typically would not know what specific plant, for instance, or race of a dog some image belongs to. Okay. So you should also keep in mind that it's not true that machine learning allows you to replace everything human work by data. You see here a headline, "The invisible, often unhappy workforce." This is human click workers who are paid not very much, only a few cents per image, to label these images, because most of machine learning is supervised learning. So when you train your model, for every image you use in training, you have to provide the information, what is the desired output. For instance, for this image we see at this slide, you have to label this with boat, yeah? And imagine the work to do this for 4 million images or more. Okay, so really impressive successes, but people seemed to have the hope that we can replace thinking in many contexts by sampling data. And this is not true. You have the work for labeling the data, and you also have to think about how you sample your data, that you avoid, for instance, unfair biases, so-called sampling biases. So we have a really high effort to obtain data in sufficient quantity and quality, especially in specialized areas such as medicine. Otherwise, the rule garbage in, garbage out holds, right? Yeah, machine learning is much more than neural networks. I show you here, and I will not go over all the bullet points here. I just want to show you that machine learning is also a long-established domain in AI, starting with the perceptron, the model of a single neuron by Rosenblatt, going, for instance, to the classical feed-forward neural networks of the 1980s. Here you also already see names which you also hear a lot about today, like LeCun or Hinton. We had decision tree learning, inductive logic programming, which is my main area of work, support vector machines, which started statistical machine learning, recurrent networks like long short-term memory, invented by 2 Germans, Sepp Hochreiter and Jürgen Schmidhuber. So you see, it's a long history. Just to give a glance about how machine learning with neural network is working, let's look at the simple model of a perceptron, which is at the top of this slide. This is a really simple approach which can only do linear classification. It's basically a linear regression problem, so it's not very powerful, and you definitely cannot apply a perceptron to image classification, right? But what you see here already is that you have an input. In this case, which is classical machine learning, you have a vector with numerical values. For instance, this could represent color distribution in an image if you want. And then you have here the weights W1 to Wn and the bias weight for the bias W0. And what you are doing is you start with a random seed of these weights. You give an input image. You, for the case of the perceptron, look whether this weighted sum is larger than 0. If yes, you would say, yes, there is a boat or a cat or whatever. And otherwise, it's equal or less to 0, you would say, no, there is no boat or cat. Yeah. So when this output calculated by these random weights is not the same as the human annotated label, you have a so-called loss, and you need this, the error, to correct your model. And correcting the model means that you change these weights. And this is all about neural networks, right? That's the general idea which is still present in deep learning architectures. Learning means adaptation of weights to optimize performance, yeah? So this simple perceptron is not very powerful. These classical so-called feed-forward neural networks are very powerful. In general, you can approximate every function, every computable function with a neural network with 2 hidden layers, given infinite many data and infinite many time. Yes, this is a theoretical result. So here in the middle, you might recognize that such a feed-forward network consists in principle of many of these perceptrons, but now we have a complex nonlinear function we can calculate because we have very complex interconnection of the different values with these edges where we have the weights. Yeah. But it's still true, training means that you change these weights to reduce loss. So a little advertisement for what we are doing. Also, I have, since more than 10 years, lots of projects to educate children about computer science in general, but also about AI. And we developed a neural network game where children can play with classification of animals with a simple neural network. This is what you see here at the bottom. Yeah, I already talked about the sampling bias, and this was one of the first kind of big disappointments after the big excitement over CNNs. Yeah, we read about gender bias in the Emerson recruiting tool. Some of you might remember this. This was the case where Emerson used historical data of previous applicants for jobs. And in this time, and this is unfortunately true still today, in the domain of software development, there have been working next to no women and lots of men. And so therefore, when they trained their recruiting tool very naively in a way with this historical data, it happened that women who applied for software developer jobs were never invited. Yeah, this was a big scandal. Or you might remember the Google problem, which is, by the way, still partially there today, where people with dark skin color were classified in the Google image retrieval as gorillas. Again, this is not because Google workers have been racists in an explicit way. They just had a problem with their sample of training data. And because the color, for instance, of the face of this gorilla you see here is dark, unfortunately, the neural network classifiers classified images of persons with dark skin as gorillas, which is terrible. We have the same problems in medicine, and these problems can also become true in educational context when you apply so-called predictive analytics, which I will come back to later. We did a small project about gender bias in machine translation. This is work with a PhD student in my team, Jonas Troles, where we investigated not only for Google Translate, but also for DeepL and other systems, the gender bias when you translate, for instance, from English to German. In German, you have gender for these relative words like der and die. And when you enter in Google Translate the Doctor Who, it will translate der Arzt der. And when you enter the Nurse Who, it will translate die Krankenschwester die. We also proposed some remedies to this problem. Typically, the strategy is to use hybrid approaches to AI, combining knowledge-based approaches with machine learning. Okay, all these recognized problems have led to the so-called third wave of AI, which is explainable AI, for short XAI. And more, this third wave was extended to further techniques like interactive machine learning, keeping the human in the loop, allowing humans to correct model decisions, and hybrid neurosymbolic AI, where you combine knowledge-based approaches and machine learning. What I want to show you here on this slide is one special method for XAI, which has been proposed by the HHI in Berlin. What they are doing, they help to analyze which information in an input image has mainly contributed to a class decision of a neural network. And now it could be that you trained your model to recognize images of horses, yeah, but you were a little bit sloppy when you sampled your images, and you got maybe a large amount of images from a database where you always have this copyright mark at the bottom of the image. So neural networks are optimization algorithms, and obviously it's much easier and much more robust to classify image data with respect to are there letters or not, than all the different forms a horse can take on an image. Yeah. So you thought you trained a really good model. It had a very high predictive accuracy, but what you did is you trained your model to look just at the copyright notice to decide whether there is a horse on the image or not. This problem is called overfitting, and overfitting always occurs when accidentally some irrelevant aspect of your input correlates with the to-be predicted output. Yeah, this is overfitting. This is also called clever Hans effect, named after a horse back in the 1920s which worked at a Berlin fair, where people thought this horse can calculate, can do sums of numbers. Actually, it was the case that it learned to react to very small body movements of its owner, and it stopped noting the count when the owner kind of relaxed. Oof, now it counted the right amount of time. So this is the infamous Clever Hans effect. So let's shortly look into human learning. We humans have a very, very impressive so-called inductive bias, which allows us to learn in a very efficient, robust, and flexible way. Look at this image here. So obviously, I cannot show you the impressive performance children have when they learn concepts like cat, dog, bowel, car, and so on, because we all know this. So the cognitive scientist Josh Tenenbaum constructed these new type of natural categories instead of cat, dog, and so on. And let's imagine you found these new species, maybe in deep sea, yeah? And we need to have names for these new concepts. And I tell you that these 3 images represent a new concept called TUFA. Yeah. When we now look at the top left corner, I don't see the audience, but maybe when you do it nevertheless, everybody hands up if you think the image in the top left corner is also a tufa. I think everybody thinks that, right? And everybody who thinks that the image below this is also a tufa. There will be no hand up now, I'm sure. So you learned this really complex visual concept, what a tufa is, from 3 examples, yeah? And this is due to the so-called inductive bias. Without a bias, what we deem relevant for generalization, yeah, we could only do rote learning, store things in a database, yeah, in our brain or in the computer, right? In the moment when we want to generalize over data, we need this inductive bias, yeah? We also, because we are such good learners, are prone to overgeneralization. When you look at the phase when children learn their native language, they do these overgeneralizations. They might say goat instead of went, because they first extract the regularities about past tense formation, for instance. Obviously, the dark side of inductive generalization is that we humans are prone to stereotypes and prejudice, like girls are not good in math or boys are not good in interpreting poems. However, in contrast to a standard machine learning models, we are able to do metacognition. We can reason about our decisions, yeah, to more or less degree. Nobody is completely free of stereotypes and prejudice, right? But nevertheless, we can reflect these things and can try to work against our stereotypes, right? Another case where you would need metacognition, which the typical machine learning system cannot do, is when we are confronted with something completely new like this tufa here, we can recognize this and can say, oh, I don't know this. Can you tell me what it is? When you train a neural network to discriminate, for instance, elephants from zebras, and you input an image of a refrigerator, yeah, your neural network would output elephant. It would not say, wow, I don't know this type of object, what is it, right? So most AI is not general AI. We humans are very prone to inadmissible anthropomorphization of AI systems and even much simpler technical systems. Yeah, some of you might anthropomorphize your computer or your car and so on. Yeah, we have to keep in mind that most AI systems are restricted to one very, very specific domain, like recognizing skin cancer and nothing else, recognizing different animals and nothing else. So this is called weak AI, and most AI systems are weak AI. A system which is good at classifying animals cannot classify traffic signs. There is no metacognition and no awareness. The problem with this term artificial intelligence is that with the term intelligence, we correlate specific high cognitive achievements. If your neighbor now in the room tells you, I'm an excellent chess player, or I do my PhD in physics, you would say, wow, you must be intelligent. If somebody tells you, I'm very good at recognizing cats, I'm good at mixing a drink or building towers from a block, you would not be very impressed because these things come very easily to us humans. But remember the definition of AI. AI is concerned with problems where humans are currently better than computer systems, AI systems. And it is much easier for computer systems to do complex mathematics, for instance, or theorem proving, than to recognize a cat. Typically, the so-called general AI means that we typically assume that if a person is able to recognize cats, it might be also able to understand natural language dialogue, it might be able to mix a drink, and so on. This is not the case with weak AI systems. Typically, it is assumed by neuroscientists, psychologists, philosophers that general AI requires consciousness and intentionality. Christoph Koch, one of the most famous neuroscientists researching consciousness, wrote 2013 in a book that he thinks that it might be possible to get so much concrete insights about human consciousness that you can formalize it mathematically and therefore implement it on a computer program. His newer book, 2020, The Feeling of Life Itself, has the subtitle, Why Consciousness is Widespread but Can't be Computed. Yeah, so I really recommend to read this book. Okay. This has been my first part. What you should take away from this first part is that AI is more than machine learning. There are also knowledge-based approaches, and with the newer approaches of third wave AI, we work on combining machine learning and knowledge-based AI. Learning is inductive generalization over examples, and supervised learning relies strongly on human input, the annotation of the ground truth labels. Yeah? Machine learning models can never be 100% correct because it's induction over a sample of training data. So imagine here, when you do a typical image search, let's say with Google, yeah, and you input baby cat on red sofa, you get results, many images. When you look at the first 100 images, there might be some images which don't show a baby cat on a red sofa, but you as a human see, okay, this is not an image relevant to what I searched for, and that's not a problem. So if every 100th image shows something different, so what? The possibility to do image search is a really efficient tool, yeah? Nevertheless, also it's not 100% correct. But what if an image-based medical diagnosis, every 100th output is wrong? So this is what AI researchers in the domain of interactive AI, explainable AI are concerned with. How can we embed AI-based decision-making in such a way in decision processes that the humans are not prone to automation bias, so unjustified trust in the output, so that we can exploit the efficient classification of AI systems, but nevertheless can augment it with human-based quality control. And this is a big, big challenge. The next takeaway is that sampling biases as well as inequalities we find in the real world can result in unfair models. But nevertheless, although I pointed now out lots of problems, obviously, machine learning has a lot of merits if it is applied adequately. So at this point, I just look in the audience once whether you have questions for this part. Otherwise, I would proceed to talk about AI in education and about ChatGPT.
So, thank you very much, Professor Schmid. And does anyone have a question so far? So if you have a question, our team members will just bring the microphone to you and you can ask the question for Professor Schmid.
I have a question. Yeah. Yeah, thank you very much so far. I have a question, a quick question. There is an ongoing discussion on we have to, especially from the politics, we have to control the algorithms and all the stuff. But in fact, and I think you said it, the problem is not the algorithm, which is just a training algorithm and the topology of a network, but it's a set of data, the input data, and especially the annotation. So shouldn't we try to control how we collect data, so building samples, and how we annotate?
Exactly. That's the crucial point. This is the most important point in machine learning, but also in statistics, in empirical research in general, that the quality and the sampling of your data has a huge impact on the quality of the model, right? And much more than different variants, let's say, of CNN architectures. Yeah.
So perhaps a follow-up question, but does it mean if we teach AI, shouldn't we focus more on not on the deep learning stuff, but on the data preparation and data labeling?
Mm-hmm. I think when you teach machine learning, this part is really crucial. So in data science, bachelor's or master's, this is of course an important part. And I think more and more it is recognized also within the machine learning community, where we don't teach this typically. Yeah? You also don't teach this in a typical mathematical statistics lecture. You just assume you have good data, right? And more exactly this part becomes important. And I think it becomes important maybe to every degree you teach at university, because nowadays nearly in every study program you have either machine learning or at least empirical research you are doing. And typically people are very, very naive when it comes to data.
So thank you very much, Professor Schmid. Just a little reminder. First of all, I'm Alexandre. Sorry, I didn't really present myself. And I will be moderating just for the questioning. And just a little reminder for the presentation. is it possible to finish with the presentation and then later at around, well, till 10:55, it was till 10:25, it was planned to have a break there. So
Yes.
is it possible for you to finish the presentation and then we have the questioning round and then have a break later?
So I plan to talk until 10:15. Is this okay? I can also shorten it.
Yeah, it's okay. Thank you very
But
much.
I promise to stop at 10:15.
Okay.
And if I don't stop, just interrupt me, please.
Okay. Okay. So we will just let you continue with the presentation, and at 10:15 we can have the questioning round and discussion.
Okay.
Thank you very much.
So, yeah, thank you. So now about AI and education. So when you look in what in general computer science, digital approaches, for instance, learning apps provide you with, you find in principle currently mostly two things. On the one hand, you find gamification. Gamification is really a suitable tool for rote learning because it's really boring to learn the multiplication table or vocabulary or capitals of countries. And obviously, you need some things to know by heart to build on this later, right? You cannot do complicated mathematics when you don't know your multiplication table, yeah? And you can't formulate, you can't write an essay if you don't know your vocabulary, right? So we need to learn this boring stuff, and their gamification can be useful for motivation. We use techniques like spaced repetition and so on. You all, I think all of you know learning apps you use. Yeah. So the other part is in discussion since some years now that it is discussed that we can do lesson management at school, at university. I didn't hear this discussion so much yet, but for schools I hear it a lot, that you want to have intelligent dashboards for lesson management where the core is learning analytics, which is in principle data-based scoring. So brought to the extreme, this would mean the following. In the school, all the children or the students, the high school students, work more and more with tablets or notebooks, yeah, and you collect from them as many data as you can. When do they turn in their homework assignment? How much are they engaged in discussion groups? Maybe this is done, for instance, in China. You already do eye tracking and many more data. Log files, automatic assessment of turned in homework, and so on. You collect all this data about huge amounts of students, and then you you teach a machine learning model where your output is, for instance, the final grade in the math exam. Yeah. So when you do this, you could, in the next step, let's say 4 weeks in the school year, yeah, use this data collected for the new students, input them in the learned model, and predict their final grade in mathematics. Yeah. You now learned in my first part of the lecture that machine learning models are never 100% correct. And you learned about sampling biases and so on. A next point, this is something you learn when you are a student in psychology, for instance, is that you have to think about the validity of what you are measuring. For instance, does an eye tracker really give you a valid information about attention. Yeah. So when you have this complex constructs like attention, motivation, academic achievement level, and so on, these things become really complicated. Yeah. And doing here just number crunching is really dangerous. So when we do this, we kind of put the need to collect data over our didactic considerations. We would now decide, oh, we do this on our laptop by default, and not think whether there are aspects when we teach which should be done by writing something by hand, by doing a discussion, and so on, right? So this is a danger. The next danger is that when we want to make assessment simple, we prefer recognition tasks like multiple choice or gap texts in contrast to problem solving and transfer tasks to determine how students learn. But, to do your assessment. But we all know that the type of exam we offer at the end of a course determines how students learn. When I know that I have just to recognize certain keywords, yeah, I do not learn how to construct a solution, yeah. And this is especially in STEM topics, but basically in all topics, I think, a real problem. Yeah. Furthermore, monitoring can result in real unfair assessment of individual students because these machine learning predictors are typically not reliable on an individual level, but on an average case. You can predict, for instance, for a hospital, whether there is danger of some bacteria spreading in some area, yeah, but you cannot really reliably predict that this bacteria will affect one specific person, right? Okay. When we look at these type of AI applications, we risk a relapse into behaviorism. Yeah? There is another part, again, this is something what I am researching, therefore I might be a little bit biased, which is intelligent tutor systems. There we work on really understanding misconceptions, give individualized feedback, and allow constructive learning in problem-solving contexts, which leads to efficacy, sorry. I will not go into details here, but talk now for the last part of my talk about ChatGPT, because this is what we all are interested in, and I bet all of you played around with ChatGPT. So, first, some basic facts. The first transformer networks were proposed indeed by Google in 2017. And Google provided us with the large language model LLM, for short, called BERT, in 2018. It's really tragic in a way that Google, especially Google Brain and Google Research, published at really important conferences like the NeurIPS, the mathematical foundation of the GPT models OpenAI and thereby Microsoft are using now. Yeah. So so OpenAI had GPT-2 in 2019, GPT-3 in 2020, and so forth. And we all remember last year, end of November, in December, when ChatGPT was released. And already in January, it had over 100 million users, which is the fastest growing consumer application up to date. Yeah. So GPT-3 has been trained on hundreds of billions of words. It is a neural network with 1 875 billion parameters needing 800 gigabyte of storage, and takes into account, when you question the model, a really large context of so-called tokens, which is basically, you can imagine this as single words or symbols of a programming language and so on. It is estimated that training this large language model, GPT-3, consumed enormous amounts of energy and resulting in emission of enormous amounts of CO2. Again, I already told you this for the CNNs. We need to be aware that this model doesn't come without human labor. In January, there was this headline in the Time that OpenAI used Kenyan workers on less than $2 per hour to make ChatGPT less toxic. Basically, these click workers had to read through huge amounts of text labeling this as toxic if it is toxic, and what is toxic is given by, of course, the standards holding in the US, right? So when you look what currently happens in Florida, for instance, with the queer community, forbidding books which school books which have queer content and so on, this might be a problem because we don't see what ChatGPT is filtering out. Yeah, this is just something we don't get. So I talked up to now not about ChatGPT, but about the large language model GPT-3, which is based on self-supervised learning. And it used data from the web, from Common Crawl, from books. The complete Wikipedia makes about 3% of the data in GPT-3. Yeah. On top of GPT-3, which has been frozen in 2021, so the model has been trained and then it stopped, like with the CNNs is the case also. But on top of this, there has been supervised learning for generating of dialogues and the named content filters. And what we all are doing when we used ChatGPT and use the thumbs up or down is human-in-the-loop reinforcement learning for fine-tuning. So the ChatGPT reception has been from completely amazed to very skeptical. So Gary Marcus, author of the book Rebooting AI, one of the big critics of generative AI, has been invited to talk at the American Congress, actually some weeks ago now, to talk about the problems we might be expect. Yeah. The Google vice president warns that AI chatbots are hallucinating, inventing stuff, which is obviously wrong, and so on. And what I already told you, these systems rely heavily on human feedback. So now look at some examples. ChatGPT can be really helpful. For instance, here, I'm sorry, this is German. Maybe some of you in the audience understand German. I asked as a German about an English proverb, and I kind of used a wrong preposition here. What do you mean by don't cry about spilled milk? ChatGPT very nicely corrects the about to over, which is the correct preposition here, and then it explains this proverb in a really good way. Yeah, very useful. However, the danger is that ChatGPT can be very eloquent and present completely wrong information in a very convincing way. So here I kept the German example because when I did this in English, it was already correct in January. In German, it is now also correct, but it was not correct in December. I asked, what is more heavy? A kilogram of cotton or a kilogram of steel? And ChatGPT, this is a joke question, yeah. ChatGPT argued that a kilogram cotton is doesn't weigh as much as a kilogram steel, and it explains this with a lot of technical terminology. Yeah, it talks about the density of the material, about volumes, about mass, about cubes, and it sounds very scientific, but it's complete bullshit. Yeah, and this is a real danger. ChatGPT is not a tool for asking questions about things you don't know. There you should go to trusted websites. Mostly Wikipedia can be trusted, yeah, but you might also refer to specific papers you can find online and so on. Okay. In January, I asked if 12 persons board a bus and 8 persons on board, how many passengers are in the bus? Again, this now works. It was not correct in January. So everybody nowadays is aware that ChatGPT has no mathematical knowledge. So the reasoning here was really fancy. If 5 persons board a bus and 8 on board, then there are 2 passengers in the bus. Work this out, please. This can be calculated by subtracting the number of persons who board from the ones who exit. 5 minus 8 is minus 3. That is, there are 3 persons less in the bus. That is 2 passengers. This is completely broken logic. Yeah. Here an example which worked yesterday. 2 children, Chloe and Alexander, went for a walk. They both saw a dog and a tree. Alexander also saw a cat and pointed it out to Chloe. She went to pet the cat. Did Chloe see the cat? No. According to the information given, Chloe did not see the cat. It was Alexander who saw the cat, and so on. Okay. So what I like to use ChatGPT for very much is to give me ideas. But on the other hand, I typically, as a scientist, want to make references to the persons who had this idea originally. Yeah. And this is not possible. So when I ask for giving me references on empirical studies, evaluating measurements to encourage girls to study computer science, nowadays, this again has been yesterday, I get an apology. And then, which is also rather new, I get some tips how I can look for references. Yeah. Okay. Some weeks ago, I had to do a short movie explaining young children how hate speech detection in social media works based on machine learning. And I wanted not to use hate speech, obviously. So I asked ChatGPT for some examples on harmless insults. I did this in German and I got terms like Faulpelz or Träumer and stuff like this. But what ChatGPT nowadays more and more is doing, it becomes very paternalistic. It tells me some harmless insults, but it then tells me, and this is nothing I asked for, remember, you need to be friendly and lighthearted in tone when using insults, that the others understand that this is meant playful, and so on and so on. Yeah. So just as a pointer, I already mentioned this, we have a very high energy consumption training these large language models. Nevertheless, I think it's crucial that Europe trains its own language models, because otherwise we become two technology consumers and we want to be technology developers, obviously. Yeah. And what we also see that these very, very large models show typically more performance than the smaller ones. Yeah, when we look at ChatGPT and compare it with other tools we have, which are not necessarily AI tools, I want to state the following. When we use a search engine like Google or Ecosia, what we have is context. Yeah, we see together with the information the web page of this, where this information is given from, and we are trained to assess the trustworthiness. Yeah, so when I Google something about some disease, and I find information on the page of a university clinic, yeah, I trust this information. When I when I am on a page of a pharmaceutical company, maybe I think their information might a little bit biased. But when I go to a web page of a healing stone seller, maybe I will be very, very skeptical about the information. ChatGPT does not allow us to refer back to the original source, and therefore we have no possibility within ChatGPT to assess the trustworthiness and the truthfulness. So we need to augment ChatGPT with other technologies of information retrieval. When you think back to the time when Wikipedia started, there have been these discussions that this will be never comparable in quality to Brockhaus or Encyclopedia Britannica. But nowadays, Wikipedia kind of won against this classical printed encyclopedias because we have high agility, and we see that humans can come up with very good strategies to do quality checks. And this is something missing in ChatGPT, but I'm sure that over the next years we will come up with such strategies to augment ChatGPT output. Okay, I see that I should come to the end. ChatGPT shows us more or less convincingly that there are many, many interesting applications: writing or correcting essays, supporting lesson preparation, designing slides, and obviously a prohibition of use also in university context, I think, is not a good idea. We didn't prohibit calculators, we didn't prohibit spell checkers, the use of search engines, and so on. It typically makes absolute sense to use technology in technological innovations to support our efficiency and to enrich our competencies. Yeah. But we should keep in mind that there might be some problems and we should be aware of them. I already talked about factual accuracy, but we have also the problem that language becomes very, very streamlined. We adopt with ChatGPT the value system of the US. We have many, many copyright questions, and what is now discussed, and this is one of the reasons Geoff Hinton gave for quitting his job at Google, that we have imminent danger of disinformation campaigns, which will be much more massive than what we already experience with trolls and human Twitter information. Very nicely, Nick Cave analyzed a song text written in Nick Cave style by ChatGPT this song is bullshit, a grotesque mockery of what it is to be human. And it's really the case when you look at computer-generated music and computer-generated art and poetry, typically this is kind of very banal. It's more like, let's say a poem for the birthday of my uncle on this level of creativity and quality. But up to now, I didn't see artistic achievements on the level of humans. So, bottom line, I recommend the book Rebooting AI by Gary Marcus and Ernest Davis. We had some weeks ago Ernest Davis as a speaker at the University of Bamberg, as an online speaker. And his bottom line has been AI has increased much more in power and widespread use than in reliability. So the problem of building trustworthy AI is not much closer to being solved, but it has become much more urgent. And this is where AI research currently is looking at, how to really build trustworthy AI systems. And I think I finish with this slide. Thank you.
Thank you very much. Thank you very much, Professor Schmid. And now we will have some 5 minutes, some minutes of 6 minutes. We are left with the 6 minutes for discussion till 10:25, sorry, and then we will have a break. So before, I just have one question, and I think many students are thinking about it. I am a student in Media and Communication Sciences here at the TU Ilmenau. So I am wondering, how can I apply AI, for example, in my studies at the university?
Yes, so there is not so much AI directly from the shelf. What you have from the shelf is ChatGPT. So maybe I should focus on how you could use ChatGPT. So I think ChatGPT is really useful. For instance, when you are a computer scientist student, for code generation, yeah. So I think President Sattler will agree that over the last years we experienced the problem that students anyway kind of use code they copy together from Stack Overflow, from Git repositories, and so on. And you could alternatively use ChatGPT for code generation. But the problem here is obviously that we need more and more time for debugging. Yeah. So in computer science education, I think education needs a little bit to focus more on how do I test and validate code. Yeah, and maybe less on code generation, but obviously we need to be able to generate good code to be able to debug and validate code, right? So I think there is a slight shift. When you look in other disciplines, like the one you mentioned, maybe you are writing lots of essays. I think it's not bad to use ChatGPT to give you ideas. Like, so I do now something classic when you say, oh, I have to write an essay in school comparing Goethe's Mephisto in Faust with Iago in Shakespeare's Othello. Can you, ChatGPT, name me some crucial similarities and differences between these two characters? And you can use this as a good giver of ideas, but then, of course, you should check in which work has scientists from the domain of literature already discussed these characteristics, right? You could use it in a very good way in transforming a text into simple language. You could use it to make a bullet point list out of a text. You could use it to write a summary of a text and so on. You should not use it to generate. So when you write a bachelor thesis, yeah, just say write a bachelor thesis about the following topics and a topic, and please include references and graphs. These references and graphs are typically hallucinated, yeah. So you shouldn't use it for that.
Thank you very much. So maybe due to the time constraint, we will take two more questions, and one person is there. Could you just shortly present yourself and then your question, please?
Thank you very much. My name is Karamba Diallo. I'm from the Gambia. And I have a question which relates to AI from a generic sense. And my question is, often I've even had experience with AI where I tried writing a paper, kind of, and I had to get involved with the app or the software. And what I've discovered is often it helps with sourcing knowledge, but it doesn't in any way help in the creation of knowledge. And I'm asking Professor if she would suggest the same thing and recognize it as a shortfall of the software.
I didn't get the last part of your question.
Yeah, so essentially I'm saying it is not in any way inductive, that it doesn't introduce anything new.
Okay.
Yeah.
Yeah. This is not an easy question because, of course, you have from the large language model lots and lots of recombination of previous information. Yeah, this is not induction, but nevertheless, by these recombinations, some novel combinations of information might be generated, and this might be interesting and helps you to get new ideas.
Yeah, thank you very much. So maybe one last question. Thank you.
My name is Thomas Bachmann. I'm a professor for vehicle engineering, completely other discipline. Having you as a renowned expert here, not here, but there in Bamberg, I want to ask you, you explained the 3 waves, and there's a certain likelihood that there will come more waves in the future development of AI. Which one would you expect as maybe a 4th or 5th wave, and maybe in conjunction with that? Could you please comment a little bit on the warnings you mentioned by Sam Altman, by Prof? You mentioned them already. Could you a little bit comment on that? What's your opinion about that? Do we have to take that serious? And is there a likelihood that this will be in conjunction with the 4th or 5th waves of the future development of AI?
Yeah, a very difficult question to look in the future. So I think the wave we are now experiencing is generative AI, right? And we have this for text generation, for code generation, for image generation, and so on, right? And I think even many AI researchers, definitely I, have been very, very surprised by the performance we experience now with systems like ChatGPT, Midjourney, Dolly, whatever, right? Codex, Copilot, and so on. So I think this is really, really impressive, but I think generative AI has lots of dangers. The biggest danger is, I think, really the disinformation problem, that you could do really big disinformation campaigns. So deep fakes is one direction where I think it becomes very obvious. And I think that it becomes more and more important to think about how we can install a human-based quality control, because in the end, it's always humans who have to decide about the quality. And this will become more and more important. So I think we will have, on the one hand, developments how to augment generative models with other technologies, for instance, knowledge-based technologies, and we have to come up with interfaces for human AI partnerships, which allows human in a efficient way to control the quality of the outputs. And I think this is, of course, a big interdisciplinary challenge. We need methods from AI to do this, but on the other hand, we need definitely to include psychology and other sciences in this endeavor.
Thank you very much, Professor Schmid. And I think this will be it for the first keynote lecture. And we are very honored to have had you here in Ilmenau for, not really here in Ilmenau, but online for the presentation. It's a real honor for us. And can we please just an applause for Professor Schmid again?
Yeah, thank you a lot. The honor is on my side. Thanks for having me invited to the Dies Academicus and your event here. I wish you a really exciting and interesting rest of the day.
Thank you very much. So now we will take a short break, and we will meet back here at 10:35 to receive Professor Daniel Lee Chen. That is a professor at the Toulouse University of Economics and lead principal investigator in data and evidence for justice reform in the World Bank. And he will give a presentation on how can AI help to be fair and just in the justice system. So thank you very much, and see you all later.
Great. Thank you all for inviting me. I'm going to ask the question today, can AI help courts be just and fair? And how do we know? So to begin to answer this question, let's begin with the definition of justice as equal treatment before the law and equality based on recognition of difference. Using the rubric of machine learning, we can think of a set of X's that should lead to the same predictions or predictability of outcomes. The X's should improve the predictions, and a set of W's that should not. We tend to think of the X's as consequences of our actions based off the control principle and the merit principle, that we should be responsible only for events under our control. And the W's might be race, gender, expressions of our identity, but also events outside of our control like football, weather, the judge's lunchtime, or preceding case. So behavioral anomalies offer an intuitive understanding of future relevance. Psychologists have documented many effects only of moderate size in the lab. So settings where judges are closer to indifference between options or more likely to lead to detectable effects of behavioral bias outside the lab. So let's suppose this parabola captures what the judge thinks is the right sentence. Small deviations cost little. The judge isn't sent to jail. Now suppose the parabola flattens. 8 months, 8 years, I don't care. I'm indifferent. Then as my preferences over the legally relevant factors wanes, the influence of extraneous factors wax. So we can think of measuring behavioral anomalies as documenting revealed preference, indifference. So I'm going to illustrate using data collected the last few years, all the cases, 1 million judge votes from 1891 in the US circuit courts, 2 billion 8 grams, 5 million citation edges. In the district courts, we have millions of sentencing decisions linked to the available corpora of their opinions since 1923. In the Supreme Court, we have speech patterns of oral arguments since 1955, clipped, identical introductory sentences, and ratings of their traits, together with data on asylum, prosecutors, World War I courts-martials, and the Global South. The data comprise a natural laboratory to study normative judgments. You're right or wrong, good or bad. So how do judges make decisions? They follow the law, of course, but not only. They're human, and they're influenced by the weather. Judges deny refugees asylum when the weather's too hot or too cold. The time of day. They grant asylum more before lunch and less after. The defendant's name. They assign longer sentences to defendants whose first initials match their own. The defendant's birthday, when they do the opposite and give the gift of leniency. NFL football. Judges are more lenient the day after their team wins rather than loses. Ramadan. Muslim judges are more lenient the longer is Ramadan. Snap judgments. We can use machine learning to predict asylum decisions with 80% accuracy the date the case opens and when it closes. Elections and wartime also affect decisions, but not only, there's the gambler's fallacy, a well-known tendency for people to misperceive random sequences. So in a series of coin flips, it's not that uncommon to have streaks of ones or streaks of zeros. In other words, any two sequences are equally likely, but people tend to think the sequence at the top with rapid alternations is more likely than the sequence at the bottom. So if I'm an asylum judge and I grant asylum too much in a row, I might worry I've become too lenient. If I deny asylum too much in a row, I might worry I've become too harsh. So if I actively might negatively autocorrelate and just trying to be fair and just flip my decisions, and up to 5% of decisions are reversed due to the gambler's fallacy. In the Supreme Court, the first sentence of lawyers' oral arguments are identical. Mr. Chief Justice, and may it please the court. So we clip these sentences and ask raters to evaluate masculinity, intelligence, trustworthiness, characteristics that previous research deemed relevant in social settings. And it turns out that male petitioners below median in masculinity are 7 percentage points more likely to win. And Democrats vote against masculine-sounding lawyers, but profit-maximizing firms would tend to erode this correlation, select the less masculine-sounding lawyers in order to win. But this negative correlation is stronger in more masculine industries, consistent with their perceiving the masculine-sounding lawyers as winners or having a taste for masculine-sounding lawyers. So we ran a debiasing experiment, and we found it reduces misbeliefs, the correlation between perceived masculinity and perceived win rates. And incentives further erodes the misbeliefs, which identifies a taste for masculine-sounding lawyers. So what about gender? Female lawyers are also coached to sound more masculine. So do our results extend? And it turns out it does. Less masculine males and more feminine females are more likely to win. So if masculine is the opposite of feminine, the pooled results would be stronger. And the results are robust to lower heterogeneity and the best machine learning model of Supreme Court outcomes, which also selects the perceptions when they're available as features. So besides the voice, there's text. And we can train a large language model on the judge's writings, and we can see that the vector associated with female is correlated with migraine, hysterical, morbid, obese, terrified, unemancipated, and battered. And the male dimensions associated with reserve, industrial, honorable, commanding, conscientious, and duty. And we can do this judge by judge, and Justice Scalia was an outlier in gender slant. And in the US circuit courts where judges are randomly assigned, judges with more gender slant vote against women's rights issues, assign fewer opinions for females to author, reverse male judges less often, and cite female judges less often. And the results extend to Kenya, where judges favor defendants of their own gender, ruling against women when they exhibit stereotypical gender writing biases. So there's at least 5 ways for machine learning to diagnose judicial inattention. Early predictability, so we can predict case outcomes, the date the case opens, and when it closes, with the same degree of predictive accuracy that would suggest the judge didn't take into account features of the case during the hearing or during the trial. Behavioral anomalies that have causal influence in the way just illustrated. Now, if we're inattentive to the litigants, we may also be inattentive to appellate reversals and have implicit risk rankings of litigants being closer to random, that is, be flipping a coin. And this difference in indifference may be greater for certain litigants, such as from the Global South. So after surprise reversals, a decision that was predicted to be affirmed but turned out to be reversed, judges grant more asylum and hold more hearing sessions. Judges vary in their responsiveness to reversal. So do the less attentive judges have implicit risk rankings being closer to random? So I'm going to illustrate using an example from the criminal justice domain where these conversations have been more salient. So suppose I'm a prosecutor making the decision to screen someone into the criminal justice system or drop the charges and send them home. Now, if I'm a robot prosecutor making the decision only based off the risk score, then the harshest prosecutors screening in most of the individuals and letting home very few individuals would be releasing only the quote-unquote low-risk defendants. And as I become more and more lenient, letting home more and more individuals, then we should start to see the higher risks, the R4s and R5s. Now, if I'm flipping a coin, I might expect to see an even distribution of risk scores across the different leniency quintiles. And then within any leniency quintile, I would expect to see the even distribution of risk scores from R1 to R5, which turns out may have happened in New Orleans by human prosecutors in the 1990s, where the distribution of risk scores for released defendants is similar for the most lenient and least lenient prosecutors. So we can apply this to asylum and now look at reversals. So if I'm a lenient asylum judge, screening in most of the individuals into the country, only screening out a few applicants, then I would be denying the quote-unquote riskiest applicants, who should see the lowest reversal rates of their asylum denials. So what do we find? We find that judges on the left have strong habits. A judge who's generally lenient in other cases is likely to be lenient in any given case. And on the right, we can assess the implicit risk ranking. So if judges are ordering their asylees, the most lenient judge letting in the most individuals on the right hand of the x-axis should be rejecting only the least safe applicants. Their appeal success should be lower, which is what we see in the more attentive judges in blue, but not the less attentive judges in red, who may be more prone to other extraneous factors, such as the weather. And this difference in indifference is greatest for asylees from the Global South. So what about prosecutors? We can see that it's flat, the diagonal, for white defendants, and upward sloping for black defendants. And in the bail context, judges released along the right diagonal for white defendants, but not blacks. So why the wrong diagonal for black defendants? It turns out screeners increase the racial sentencing gap. So on the left, we have the black-white sentencing differences. But because black defendants are less likely to have their charges declined and sent home, the real disparity magnifies on the right if you impute a sentence of 0 for those that are sent home. So is statistical discrimination the reason for this disparate screening? So we can look at the identity of the prosecutor. We can see that white prosecutors screen in fewer cases that result in lower sentences. So it seems like they're letting in different types of cases. Now, if we're targeting the most severe cases, you might expect the white screener cases to have longer sentences. So it suggests it's not about statistical discrimination. So maybe they're just more lenient, but when the prosecutors are in a trial, the white trial prosecutors obtain longer sentences. Most district attorneys in the US are elected, and they want to appear tough on crime. So why are the white trial prosecutors more effective in this goal? And it turns out partly due to the identity of the judge. Black trial prosecutors and white judges render shorter sentences, suggesting the interaction of hierarchy and race. Black trial prosecutors and black judges on the right render similar average sentence lengths as white trial prosecutors do. And they eliminate or reverse the racial sentencing gap, which is hard to explain as statistical discrimination rather than in-group bias. So when we look at the judges, we can see revealed preference and difference. The name letter effects only appear for black defendants with the label of N as opposed to B, which highlights the potential for labels to increase recognition and respect, labels that social movements have aspired to change the circumstances of disadvantaged groups. We can also see revealed preference and difference for unrepresented parties and asylum, who bear the brunt of mood effects. So we see a number of behavioral factors to influence judges' verdicts, but there's been another factor that's been very influential. By 1990, 40% of federal judges had attended an economics training program, and the results of these seminars are dramatic. We can see economics language used in academic articles become prevalent in opinions. We can see economics trained judges changing how they decided. We can see them impacting their peers, economics language traveling from one judge to another and across legal areas. So economics likely changed how they saw the consequences of their decisions. In economics cases, they changed by 10% the direction of their votes. So if we teach judges that markets work, they'll vote to deregulate government. If we teach judges that deterrence works, they become harsher to criminal defendants. And in the district courts, when judges were given discretion in sentencing, economics-trained judges immediately rendered 20% longer sentences relative to the non-economics counterparts. And economics-trained judges are harsher to minorities. So part of the reason why economics was likely influential is because it provided theory for judges to understand the patterns they saw. But maybe we can go further. If judges are shown the behavioral biases, would become less prone to these behavioral anomalies. If judges are taught the theory underlying the cognitive bias, would become better judges. And would better justice increase cooperation, trust, recognition, and respect? So in the last century, we've witnessed what Carl Polanyi might call the great transformation of American law, where mentalities changed to be more economical, as reflected in word frequency accounts, in court opinions, where retribution was more popular in the 1800s, then followed by rehabilitate in the 1900s, the idea that people are malleable, and then by deterrence in the 1970s, when economic theory articulated that deterrence can substitute for low detection probability. So maybe this century, AI can bring about the next transformation of law with a focus on legitimacy and fairness. So I'm going to illustrate a couple possibilities through work conducted with the team, du jour, Data and Evidence for Justice Reform, that works with judiciary's interests in administrative data, machine learning, and randomized control trials to evaluate the effects of justice reforms that can spur sustainable development and reduce poverty. The reason we can do so is the confluence of two factors: the shift from paper trails to digital ecosystems at a large scale, and the advent of machine learning tools that can create interpretable data from unstructured text, even predictive models of decision-making to better understand biases in a manner previously illustrated, and now address them with digital interfaces. So for instance, as an exercise of practical empathy, we built this app for the managers to understand their conciliators. Maybe the ones that spend more time, are more attentive, and more successful. But it turns out it's the opposite. But maybe it's another factor. They could look at the data in different ways. Maybe it's the caseload. They can drill into the data geospatially to hotspot for trouble areas, look at certain time periods or types of cases, send conciliators reports, compare them pairwise, have the top ones share advice to the bottom performers who can ask structured questions to the top performers. And as a management tool, we can observe the causal hypotheses they wish to explore, which often motivate the innovations to study that focus on efficiency, WhatsApp access to virtual courts, Uberization of case backlog, apps for missing cases, open access legal search engines, or they focus on training, personalized case-based teaching, or the predictive self. So we like to follow the model of building institutions that help individuals generate their own best policies. Open source, no-code tools for data entry and decision support, understanding citizens' needs, learning best practices, and increasing recognition and respect so we can have a more just society. But let me take a step back and ask the motivating questions that drive many of these different innovations in technological apps. When you look across countries, we see an association between economic development and the quality of legal institutions, however you measure it. The enforcement of contracts, the speed of justice, efficiency, and fairness of law. But is this association causal? Does the quality of legal institutions cause economic development? For example, does a 20% decrease in case duration cause a 10% increase in GDP per capita? And if so, why? And what can we do based off this knowledge? And how can we shrink the cycle between historical analyses of observational data to societal change? A key question is the potential for digital platforms to increase access, efficiency, and fairness of justice, and reduce market-level constraints to economic development. So I'm going to illustrate with a national randomized control trial conducted with the Kenyan judiciary, a national study of India's free legal search, a study of one of the world's largest court construction programs, and e-justice innovations in Chile, Peru, Colombia, with an eye towards economic consequences. But these issues of poor quality of legal institutions are not limited to a handful of countries. In India, there's 33 million cases pending. The average case takes 8 years, as judges are constantly rotated across the cases. In Pakistan, there are 3 million cases pending, where there's only 3,000 judges. Across the world, the endless adjournments of cases on frivolous grounds are a major cause of case backlog, as this Kenyan Chief Justice had gone on the record to say. So whether it's due to the litigants, or the lawyers, or the judges dragging on the cases, the endless delay creates a problem for rule of law. So what we do is to develop an algorithm to identify the greatest sources of court delays and present this in a nationwide experiment. So in one group, we had actionable information, that is interpretable machine learning based off the algorithms. In another group, we also had accountability. The same information was then shared to prominent citizens in the local community. And a third was the control, the status quo, no information, and this was randomized across all 124 court stations. So can data science reduce information fictions, improve the functioning of courts, unlocking the positive effects of justice on economic development? There is, of course, a large quantitative macroeconomic literature documenting that higher quality justice systems are in fact associated with economic development. We contribute to this with causal evidence using a randomized control trial that a more effective justice system does in fact have developmental consequences and shed light on the mechanisms. So accountability was key to reducing adjournments, especially initiated by external parties, the one potentially frivolous. And the effect sizes suggest 20% impacts, and they compound, because if you're less likely to adjourn a hearing for another hearing that's adjourned for another hearing, and the average number of hearings per case is 4.6, this translates into a reduction of 107 days in trial length, or 22%. There's no adverse impacts on the usual proxies for quality, the judgment length, the number of cases cited in the text, or the number of citations that a case accrues. nor are there adverse impacts on citizen complaints. In fact, the opposite. When asked what suggestions do you have for improving court facilities and services, you see a reduction in complaints about speed and quality. Turning to the Kenyan Continuous Household Survey that the government uses to measure wages, industry, and contracts, we see that wages of individuals in the county is positively associated with the proportion of treated court stations in that county. And it's not any particular time period. The effects seem to persist quarter by quarter after the reform. And they're more pronounced in contract-intensive industries that you might expect to be more reliant on the contracts important for market exchange, trade, and economic growth. It's robust to different ways of looking at wages, but what's particularly interesting is the final column. The individuals are asked if their labor contract is a written contract, a verbal agreement, an implied contract, or not a contract, and we find more written contracts after the reform, which is indicative of citizens feel more confident issuing and signing contracts. So in a country where only 14% of individuals are reporting written contracts for their working arrangements, this highlights how transformative data science for justice, information about courts can be for economic development. So what about information on legal rules? Around the world, access to legal information can be limited and hard to access, and even when available, dispersed or hard to parse. So can digital platforms offering free legal information improve economic development? So we study India, the world's largest common law country, where the vast majority of its citizens lack access to the expensive commercial legal search platforms. We look at India's Keynote, which was founded by an overseas graduate student whose goal was to bring knowledge of the law to the common person. So he basically created a Yahoo or Google search engine that allowed for the automatic determination of the most relevant clauses in the judgments through keyword searches. And today, it's the first stop for lawyers. At the average page, receives 6 minutes of view time. At any given month, there's 2.9 million search queries and 1.5 million search sessions. So looking at a database of balance sheets of firms comprising 70% of India's industrial output, whether you look at firms with at least one case or look at all the firms, the sizable impacts on assets and reduction of bad debt reinforce the findings of a recent study finding that 12% increase in employment from providing free legal information to South African firms. So this highlights the potential for open source, open access tools with marginal costs near zero for adaptation or experimentation to be transformative for development. So information about courts so they can be more effective, information about legal rules so that individuals know their rights and they can have due process and be heard. What is the impact of access to justice? So in 2012, Kenya embarked on one of the world's largest court construction programs. Half of these courts had exogenous delays in construction. We find that completed courts increased court satisfaction and access to justice, particularly for the disadvantaged. It increased court performance, reducing case delay by 25%, and it increased firm investment, especially in contract-intensive industries. So we see how important court efficacy can be for economic outcomes. Court speed seems to matter. But around the world, for example, in India, you constantly transfer cases to different judges. This will result in longer case durations. And other studies find that when you randomly assign firms to faster panels, this increases their productivity. So how can we help courts be more effective? Many countries use productivity quotas, and judges respond to it, but hastily at the end of the month in Croatia. And these hastened decisions are more likely to be appealed and adversely impact firms. So is there a smoother way? What about dynamic point systems, like a legal Uber app, applying sharing economy principles to balance workload across courts and keeping cases to the same judge rather than having them transfer, or recommending the more successful mediators to cases? To do so, we need data. In many parts of the world, the data can be disharmonized, disaggregated, and scattered Excel spreadsheets. But open source tools can harmonize data entry and provide decision dashboards, which result in increased speed in appointments and reduced case delay without adverse effects. And data dashboards alone can improve case outcomes. Seeing statistics on the self can increase settlement rates and improve judges' performance. Seeing statistics on the self can increase case resolution rates. So we see that dashboards and web apps for smart assignment can improve court systems. What about e-justice more generally? E-filing reduces case duration and increases access to justice, particularly for smaller parties. What about e-courts? So during COVID, Chile innovated with WhatsApp access to courts. For Q&A, video and audio also enabled. The receivers were given text to copy and paste, which raises the potential for chatbots to help with the humans or when they're not working. The documents are linked, and the cases are linked across the calls and into the courts, facilitating downstream analyses on consequences. And during COVID, 40% of the inquiries were gender-related as it was rolled out nationally. In India, chatbot and WhatsApp improved the settlement rates and fiscal recovery for the state in online dispute resolution. So from WhatsApp to Zoom to the metaverse, as a Colombian judge recently pioneered, the first instance of a virtual reality courtroom held for a real trial. But this raises the question, can we personalize debiasing to the ear of the listener or the eye of the viewer? Cognitive psychology suggests that we have limited and perfect reasoning capacities. Gambler's fallacy, mood, time of day, order, they all highlight the fragility of the courts, where even in the US, there can be but 7 minutes to decide an immigrant family's future. So policy discussion tends to evolve around having AI replace the humans or suggest the optimal decision. But this has led to backlash, whether because you're using biased training data, which results in the so-called optimal decision, or because you reduce the autonomy in the discussion of the human judges. So consider an alternative approach that builds off the ideals of the Enlightenment and Romantic era of the self, self-improvement, self-understanding, an incremental approach that shows decision makers to predict itself and then uses predictions of errors to nudge. So in stage 1, you might have AI as a support tool, pre-filling forms. We're all used to this now in our emails and text messages, but only using the legally relevant features to train the model. So if I'm very behavioral, affected by many different factors, then the predicted self would do better than the human self if the prediction is not using all those extraneous behavioral factors. At the very least, we can increase consistency, leverage self-image motives, and deviating from the default can facilitate conscious deliberation. In stage 2, we can use all the features. And then if a decision's predicted to lead to error, we can accompany with a nudge, pay more attention, spend more time, rather than a checklist, which can impose more bandwidth. This can save time and energy to focus on the novel and complex cases. In stage 3, we may want explanations, interpretable machine learning, a reason for why this deviation has led to mistakes, which elevates the AI to the role of a coach. Psychology research has found the more people feel their autonomy is protected and that they're in control of the conversation, able to choose when feedback is given, the better they respond to the feedback. In stage 4, we can have a dialectic. So it's always possible the AI doesn't have access to private information or changed circumstances that are legally relevant, in which case the AI would steer the human off course. So we can allow the decision maker to express themselves and also have the AI learn from the human about the changed circumstances that are legally relevant. In stage 5, we can have a community of experts. So you can look at the predictions of others, perhaps in a drop-down menu, or you can get advice from a particular decision maker or role model. Or if you want to protect privacy, you can show a statistical distribution. You can also use this to train novices who might make more mistakes, or the experts get input a preferred decision. You make this open to the public for transparency and accountability, like in the Kenyan study. Or you can use feedback from the dialogue stage as a recommender system with A/B testing to generate causal evidence on what is actually the changed circumstances or private information that's legally relevant and has improvements on decision making. A/B testing already happens in the judiciary. Sentences are not randomly assigned, but cases are randomly assigned to judges who can be predicted to be harsh or predicted to be lenient. So if you assign a case to someone who's harsh or lenient, you can look at the long-run impacts of that long or short sentence length on their future lives. In the US common law, judges set precedent for future judges to follow. And biographies predict the decisions. Minority religion judges prefer to separate church and state. But you don't have to use biographies. You can use the history of how they write or how they cite in the other cases in a machine learning step to predict the decisions, predict to be harsh or lenient, and then a second step, do causal inference on the impact of decisions, such as environmental decisions, rulings in favor of environmental regulations, reduce air pollution, and you can apply this to India to look at water quality and infant mortality, which raises the potential for automated impact analysis, where you can look at the nearest cases to any given case, the assignment of judges to those cases, predict the decisions of those judges, and look at the impacts and also the disparate impacts that a ruling may have. So would informing people about the impacts of their decisions increase intrinsic motivation? Renewed attention on disparities in the justice system has highlighted the importance of training of public officials. Globally, an issue, in the US alone, it allocates $10 billion towards training civil servants a year. But despite its significance, there's limited randomized control trial evidence on what works, whether of training judges or cultivating the post-sociality of civil servants for state capacity. So besides selection, incentives, and monitoring in the way previously illustrated, I'm going to focus on training attitudes, preferences, and beliefs, the schools of thought that underlie decision-making, such as economics. So what about econometrics? Training deputy ministers in a school of thought associated with the credibility revolution for understanding the causal effects of policies through a book lottery, videos by the authors, graded summarization and visualization exercises based off social emotional learning, and presentations to their peers, increase their demand for causal evidence, and increase their receptiveness to causal evidence. The treated policymakers' performance in national research methods and policy exams improves, and commissioning of RCTs and policymaking increases. And in their official duties 1 year later, they were twice as likely to choose and triple the funding for policies with RCT evidence, especially if their prior beliefs are below the evidence from the RCT. So what about a friendlier economics, say effective altruism, rather than focusing on deterrence, thinking about whether the decision maximizes some welfare of the organization or society? So we randomized different ways of cultivating post-sociality, one that focused on the utilitarian value of empathy, and another on the malleability of empathy based off the growth mindset school of thought. And we found that the training the utilitarian value of empathy rendered greater altruism, and it increased the mentalizing on the consequences of decisions. Blood donations doubled, but only if the blood bank called for the matching blood type. Orphanage visits and volunteering increased, and amid official duties, 1 and 2 years later, ministers were more likely to choose social policies and recommend fourfold funding for them. And the book lottery illustrates the mechanism for altruism in action. The demand for learning drives the long-term impacts. the policies are influenced by treatment only when the book is assigned. AI training and AI fairness activism also impacts the attitudes of the ministers and the subordinates, and digitization funding, which is antecedent to AI, but is not necessarily the same as AI. And amid land record digitization efforts, AI training improves the resolution of land disputes, and AI fairness activism worsens the resolution of land disputes, highlighting the potential unintended consequence of certain schools of thought that can be influential in impacting citizens' lives. So another school of thought that's been influential in half the world's population is the women's rights movement. But slow progress in some places speak to the stickiness of norms. So can we shift the attitudes of frontline civil servants? So we had the teachers watch a visual narrative that was an award-winning movie, partly developed at Johns Hopkins, 5-page curricular outline, and we found that it shifted the teachers' attitudes to be more progressive. They were more likely to sign petitions to criminalize dowry, abolish polygamy, and they became less biased in their gender IATs. And their rights attitudes are obliquely transmitted to the students, whose achievement increased, but only in the mixed gender study groups, where they also increased the cooperation and coordination with the opposite gender. So students looking up to teachers can explain oblique transmission. Why do role models matter for norm change? Role models mattered for COVID vaccinations, and cash attendance did not in this study in Pakistan, reducing teacher absenteeism, and increasing student achievement. But empathy was key to elevating the receptiveness to the messenger. So progressive gender attitudes can be fostered and transmitted through role models. What stymies rights revolutions? Progressive gender rights increases stress, increases domestic violence. Novel nonconformist ideas can be fostered, but it comes with costs to the norm subverters, which dissipate once the new norms diffuse in society. So are there principles that apply from these studies to the training of judges and also to the human-centric AI approach? Self-reflection, demand for learning, community for norm change. I'm going to mention 3 experiments that touch on the stages from the incremental framework, experiments conducted with the Judicial Training Academy of Peru that trains thousands of judges and prosecutors every year seeking promotion. So they're working on a transition from theory to case-based teaching. And in this 2-year engagement, we engaged in 3 light touch interventions. Socratic method, a pedagogical innovation from antiquity focusing on reflective inquiry. So the judges were asked to think critically, challenging their own assumptions, their teachers' assumptions, and their classmates' assumptions about the materials covered in class. The control were simply reminded to take notes. We found that Socratic treatment increases performance. They were more likely to pass and increase their grades. And the click data shows the effects are larger if they finish this 4-minute video. Socratic training also reduces motivated reasoning. They were 6.5 percentage points more curious to get information related to a Supreme Court case vignette decision that they were making. Community of practice is a pedagogical innovation focusing on regular and concrete learning from peers. The peer met the teacher to provide feedback on their teaching strategies, case method, role play, student participation. We found that the treatment increases grades and satisfaction, and over this 10-month period, the treatment increases case clearance rates. It was larger for females. They had higher grades and satisfaction in the treated classes, and it reduced gender IIT bias, especially for the male judges and prosecutors, which highlights the potential for cultivating active interactions in mixed groups to reduce implicit bias that may underlie the stereotyped decision-making, snap judgments, or inattention that I was describing in the first third. So around many different organizations, people have tried to directly address implicit bias, oftentimes through training programs. But there's weak evidence for their effectiveness, perhaps in part because they're compulsory. But the more people feel that their autonomy is protected, according to psychology research, that they're in control of the conversation, able to choose when feedback is given, the better they respond to it. So does the choice to learn about implicit bias reduce implicit bias? So judges randomly assigned to have the option to take the IIT became less biased in their IITs. So what are other ways to increase recognition? Teaching civil servants about the malleability of the disadvantaged reduces implicit biases, which can be relevant for debates on disparate treatment or sentencing severity. Now, many of these interventions were delivered digitally, so can digital platforms increase recognition respect through better measurement of normative commitments? So what about personalized case-based teaching using machine learning and the history of a judge's own decisions to evaluate how the judge would decide on a case similar to the curricular example that the Academy is teaching in this case-based methodology, i.e. show them the predicted self, bringing case-based teaching to the next level, but also a digital community of practice or digital role model, because you can access the predictions of others, how they would decide on that curricular example. And then put in the real world, it could help create a culture of precedent. Now, evaluating courts is not only about economic outcomes. It's also about the perceived legitimacy of the justice system, which is typically measured by surveys. So can AI help citizens be heard? Talk is cheap. Trump, Brexit, these are mispredicted. Existing survey technologies rely on Likert scales developed from the 1930s. So what about tools from digital democracy that make costly the expression of moral and ideological beliefs in surveys? Using a revealed preference heuristic, the marginal benefit of an additional vote scales linearly, then so should the marginal cost, which implies a quadratic cost, otherwise known as quadratic voting, except applied to surveys. So on the left, we can see the potential problem with Likert scales when asked about equity and gender equity and pay. You see that responses are highly skewed, with many people giving the politically correct response that they're very for gender equality. But when it becomes more costly to express the intense preferences, the responses are spread out. And women are right-shifted relative to men. So can these survey technologies and AI help distinguish between individuals, predict behavior, and explain variance? In other words, can we identify who cares? For example, on laws making it more difficult for people to buy a gun, in the center column, in the center panel, you can see that responses are skewed to one extreme or the other. You don't have as much ability to distinguish between those who care about gun rights or gun control. But with quadratic voting on the right, we can see that we're better able to predict donations to NGOs that support gun control or gun rights. So quadratic voting is better at predicting donations. What about revealing self-interest? So for the gender equity and pay question, in the middle column, we can see that it's not too easy to distinguish between men and women with Likert scales. But on the right, we can see a better ability to discriminate between the individuals. And the fit is potentially nonlinear, which raises the potential for machine learning to do this in one step. Survey design often approximates a prediction problem. The goal is to select instruments, the tools, or the questions to best predict the value of an unobserved construct or future outcome. So in step one, we can build a model using the survey responses and the demographic covariates and track the prediction error of some behavioral outcome of interest, like donation. And repeat this for each survey method. Then estimate the treatment effect based on the prediction error and apply policy learning, which maps an individual's covariates to the survey design that results in the lowest prediction error. So when applied to this context, we can see that when we're trying to predict donations, quadratic voting outperforms Likert for the majority, especially for the middle education group. These tools are modular and extensible. You can collect court user satisfaction surveys. They're also self-service, giving civil servants and citizens the ability to ask questions of each other. So we've seen a few ways how AI can increase access, efficiency, and fairness of justice, and hopefully reduce market-level constraints to economic development. Whether it's facing the judges or whether these tools are interfacing the citizens. In the last 35 years, we've seen an increase and decrease in multilateral organizations' interests in justice reform. But given the sizable economic benefits of some of these reforms, the intrinsic value of justice and tools to measure this value, should we invest more in justice? And more importantly, what questions do you want to ask? So thank you.
Thank you very much, Professor Chen. So now we will take a round of questions. So if anyone has a question, you can ask now. But before that, I can just go to my question because I have a question. And Professor Chen, you mentioned how AI helps in the justice system. And I was thinking more about fairness. So fairness develops more considering the background of each society and also each individual. So how do AI process this fairness in the decision making concerning the justice system?
So I was intending the first slide to keep at top of mind what we think about as fairness. These are perhaps American idioms of equal treatment before the law and equality based on recognition of difference. So the first one would be, if I do a bunch of things, violate the law or do things that are meritocratic, I should get equal treatment under the law. These X's should, lead to the same outcomes, even the same predictability of outcomes. And the second one is to say that, many times when we talk about fairness, we're thinking about, there are protected characteristics of ourselves. We don't want society to be treating us differently because we happen to have, that we're taller or shorter or something. And equality based on recognition of difference would say that those outcomes should be orthogonal to those characteristics. And so making sure that whatever we do at the end with AI, we try to meet these twin criteria is important. And there we have a million flowers to bloom on how we can do this.
Thank you very much. Does anyone else have a question? Yeah. We'll just come to you.
Okay, thank you so much for the very informative lecture. You pretty much answered most of my questions, but I still want to ask that since there's a lot more resistance towards using AI to take up tasks that are usually boring and menial and things that we don't want to do on our own anyway, we don't really want something not human to have more, decision-making power. How do we, based on the presentation, it would be pretty helpful to provide AI a more frontal and decision-making role, not just as a helper, but how would you combat the resistance towards this idea?
It's a great question. So I like to think that the first thing we should do is compare with the status quo, and that status quo is human decision-making. And if the human decision-making, the real self is already, very biased or fallible, we can do this part without putting AI in the field, right? We can do all this training of a model on the predicted self and look in the data before putting an app out and see, is the human self doing better or worse than the predicted self? So think of that as like stage 0 or A of clinical trials, where before you decide you want to put anything with actual people, we can do this first, and then hopefully with better understanding of causal evidence, how to evaluate causality, how to understand what is fair and what is biased in the human decision making, we might then have more of an appetite for understanding how AI can improve the status quo.
Thank you very much. I hope that answers the question. Does anyone else have a question? Yeah. And could you just please also shortly present yourself before giving the question? Thanks.
Good morning, everyone. My name is Mohammed from Senegal. Thank you for this lecture. I just want to ask, since the data that we are putting into the AI is biased, like is there a threat that the AI itself will also become biased?
Right. So, one part of the answer is to, take this as a preliminary step, compare the, is the current status quo with, real life human already somehow more biased than whatever we do with machine learning. The second part, I think, is to address the question that, if there is, this is what their first lecture was talking about with feedback in the loop frameworks. If there is information that the decision maker has access to, that the model doesn't have access to, and this information, is important, you can just express it. You can correct it. And that should, with enough sort of pushback, we should be able to address the bias. In fact, that's how people were training the machine learning models in this morning's talk, is that, there's corrections that people have to make, and this is one way to do that. In a way, this is also a little bit how common law or Wikipedia sort of works, is that someone says, I dissent, or I want to change the precedent, so I gave you my reasons. So in a way, this is already something that society is sort of used to, and but it's a very important thing that we should be aware of.
Thank you.
Thank you.
So I also have another question. It will be two questions. First of all, you talked earlier about common law. So how do AI also process the different laws? Does it do so? Why in the decision making? That's, for example, does it process a case considering the criminal law, the common law, or how is the process being done? And the second question is, in your presentation, you mentioned gender and race, how the AI also processes these variables. But does it also process disabilities? If yes, how does it take it into account in the decision making?
Okay. So first question, at least from what I've seen, each country is trying to do sort of their own initiative in building some AI or language model, relevant for their country, and they'll also, not surprisingly, will apply to the law as well. So I don't think anything here, other than sort of these frameworks for thinking about the efficiency of court management rather than like the final decision making, nothing here is really sort of like a one-box-fits-all kind of thing. Though I do speculate from this morning's talk, when she talked about ChatGPT, if you were to create like a giant pipe and feed in all the cases of a country's laws and past decisions, could you then say in the next window, what is the most similar case and or decision? But that's an aside. On your second question, in terms of gender, race, and disability, I think this is where labels matter. Not just labels from this morning's talk, not only labels from when I talked about revealed preference and difference, where groups would militate for recognition and respect, because probably what goes on with a lot of these large language models is it just sort of absorbs it from whatever's been written. But a lot of times it's when people say, all right, this is an important variable or column to keep track of. I add it to my spreadsheet, and that then can start to help make decisions be fair with respect to disability.
Thank you very much. So that means, if I understand well, that means at the end, the decision is made by the judge, and the judge will maybe just base his or herself on the variables that the AI will provide, right? I correctly understood.
I think that's all very, maybe 2050. I'm still talking about 2023. We're not seeing that so far anywhere. Yeah, I think even, let's see, I think the closest examples to AI being used so close to decision making, there's like Compass, which is trying to predict recidivism. I think in China, they've some AI prosecutor to like predict the charge based off of the filings. There's some discussion of small claims in Estonia and the UK where a decision could be made, but it's like very simple cases and there's room for appeal. So I believe in those instances, those cases are so simple, it's kind of like you punch in a web form. And those web forms are giving the court or the judge or the program what are the relevant features to consider. And so maybe that sort of answers your question, but I don't know if disability is entering, it probably isn't something that's in the web form, right? If it's not even there, then it can't be part of the decision.
Yeah, thank you very much. And does anyone else have a question? Yeah, here, and then there.
Going along with the question you already answered, isn't there also a danger in exactly this, that AI is taking over decisions, especially if you think about authoritarian countries or authoritarian systems that like have also a different set of like ideas or values how to use this, because as I see it, it is very good to speed up things, and then to cause also maybe a lot of damage in that sense.
Yes. So there's a great body of work on, I think recently, AI-tocracy, on how autocracies might be pushing a lot on AI precisely for this command and control reason. So I would like to, one part, sort of think, what's the status quo? And as far as I understand, in the China setting, it was explained as trying to curb corruption. So maybe their corruption is like a much first order concern relative to, but understand that we all have different normative commitments and criteria on how to evaluate certain interventions, and this would be one example of it. So weighing the benefits of these types of tools to curb corruption, or have whatever might be unseen and still protect a little bit more autonomy. I don't have a skin. Sorry, I'm getting the idiom mixed up, but you know what I mean.
Thank you very much. So we will take the last two questions, and here, maybe let me come to you. Okay, nice. Okay, thanks. Does anyone else have a question? Yeah.
Hi, everybody. My name is Abdul Razak from Tanzania. Thank you for the presentation. It's really convincing that we need to shift to AI in our justice systems, but I'm really interested in about accessibility. You do know that when it comes to justice in the third world country, it's really severe. So even though the AI can be implemented in the Western countries where they're like really developed, but it's almost like, refurnishing already well-polished furniture, but where the justice system is really needed. People hardly have internet. How are we planning on implementing this there? Thank you.
Yeah, no, that's a great question. It's very important. There have been many studies on the importance and impact of internet broadband on many of these different things. One thing that maybe could sort of put into the conversation is, at least to the extent that you are saving some costs with these tools where broadband is available, then you have more resources to go and help the ones that don't have as many resources or internet broadband to access these things. So as long as you're sort of keeping that in mind, that if you are doing some intervention that has potential redistributive/disparate social consequences, that we also think about paired policies that, I don't know, maybe drive a van out to the countryside and set up the wires or whatnot for the court and the access to justice.
Thank you. Does that answer to the question? And maybe one last question to end for today.
Okay, thank you. Good morning to all. I am Yankuba Mane from the Gambia. Very insightful lecture on the AI and the justice system. My question would be on the issue of ethical dilemma, issues bordering ethics. I just want to put these questions to you. What are the ethical issues bordering on the use of AI in the justice system, and how can they be overcome? Thank you.
Yeah, I think there's a large number of risks, not only including some of the ones that have been brought up, like potential bias in the deployment of the tool, the fact that people may lose training opportunities if you're not struggling with things and you're just giving something off the shelf, you just start to become more automatic. I like to think that many of these so we should think about these and then try to map them onto something that could be measured so that we test and see, is it more on the pros or more on the cons? And then there are actual ways, so most of what I've been describing is randomized control trials under the development economics kind of paradigm. But there are new paradigms coming out from computer science, like adaptive learning. So if you find out that one of the treatment arms has bad consequences, it's really, really something that calls for the arm to be stopped, then you can do that. Or if you start to get some inkling that it should be stopped, then in the second wave, you reduce the fraction of individuals that are sent to the treatment arm until eventually it just sort of isn't there. So that's kind of how I like to sort of think about where we can go from the ethical concerns to measuring them and then weighing it against where we have in the current status quo versus a potential future, whether it's utopia or dystopia.
Thank you very much. So that was the last question, and we also thank you very much, Professor Chen, for coming to Ilmenau. Professor Chen flew all the way from Toulouse in France to Ilmenau to give us a very incisive lecture on how AI could help or assist courtrooms in the justice system. And we have a little package for you that we have prepared. It's just a little package just to thank Professor Chen for his time because he's very busy, Charlie.
Yeah. Thank you. Thank you.